Hello and good afternoon, and welcome to this video tutorial on MPLS LDP Session Protection. So let's first talk a little bit about what the MPLS LDP Session Protection functionality is going to provide for us. So if we take a look over here to the right hand side, you can see that we have what is going to be, for our purposes here, is just basically an MPLS core, right? So this is our MPLS core, and we're interested about the label distribution protocol adjacencies between router 7 and router 8 on this link right here. And so to talk a little bit about LDP, so the label distribution protocol, when it's enabled, and there's a number of ways you can enable it, you can simply type in MPLS IP at the interface level, or you can type in MPLS LDP autoconfig for the specific area, the OSPF area, that you're running MPLS in, if in fact you're using OSPF and not ISIS or EIGRP. So I've got it enabled on the interfaces here. And so what happens when I type in MPLS IP is the LDP label distribution protocol is going to start up, and it's going to send multicast hellos to 224.0.0.2, which is the all routers multicast, and it's going to send these as UDP on port 646. And so what's going to happen is router 7 and router 8 are going to send these hellos back and forth, and they're basically saying, just like if you think about it, it's very synonymous with what happens with the OSPF hellos, is that on these directly connected links, these two routers are saying, hey, I'm capable of speaking LDP, and I'm looking for others on this link who would like to form a label distribution protocol adjacency with me. And so once those LDP messages, the hellos, are sent back and forth, and the two routers both agree that yes, I can speak LDP, so let's form an adjacency, you have what transitions into a TCP session connection. Now again, the key to remember here is that this link right here, these are directly connected. So if this link goes down, it's going to destroy the LDP adjacency. And so that's where session protection comes into play, is if I have another route to get to router 7, and as you can see from router 8's perspective, he could go to 5, 6, and then to 7, or he could go to 9, 6, and then to 7. So he has two additional avenues through which he can reach router 7. However, they are not directly connected. So by default, the label distribution protocol is only going to send hellos across the directly connected links. And so this kind of leads us to the conversation of the difference between an LDP link hello and an LDP targeted hello. And so what we have right here, right, this would be a link hello, because again, it's on this directly connected link, and it's simply going to be UDP port 646 to start, and then it transitions to TCP port 646 for the establishment. However, there are hello messages that continue to go back and forth, and we're going to take a look at those. So this is a link hello, but an LDP targeted hello is allowed to go over non-directly connected links. So if router 8 was configured to send or receive targeted hellos, they would go over, these would be LDP targeted hellos. Because again, the targeted hellos are not going across the directly connected link. And this next point is very important. With LDP, if I set up session protection, in fact, what I'm saying is that the connection, like if I set up session protection on router 7, if I set up session protection on router 7, from that point forward, What I'm saying is I'm going to be sending targeted hellos. And so in effect, session protection is synonymous with the sending of targeted hellos, because what you're saying is, as soon as I enable session protection, I'm going to start sending targeted hellos. So let's go ahead and take a look at that here as part of our configuration. So if I were to say show MPLS LDP neighbors, you can see that I already have, and if I do a show run interface E01, I have the MPLS IP command on interface Ethernet 01 on both router 8 and router 7. And so you can see here that the TCP connection has been established. We can also see that router 7 is serving as the server, right? Because the connection is coming into port 646 from router 8. So we would look at router 8 and say router 8 would be the client. He's the initiator of the connection to the server side, which in this instance is going to be router 7. If we look up here, it's just the opposite, right? Router 7 is the initiator. You have your random high port, and then where is router 7 connecting to? He's connecting to router 6, which is up here on port 646. So we would say that 7 is the client here in its connectivity, LDP adjacency with router 6. However, with router 8, when we look at router 8, we can clearly see that router 8 is the initiator and that router 7 is serving as the server, right? Because the connection is being terminated on port 646 on router 7. If we expand this out and we take a look at the neighbor detail, right? And this is where we're going to want to look when we come to see how the session protection is functioning, right? So you can see we've got the peer identities here, and just a quick note. So the LDP ID, right? And so this is it says ident, but it's just LDP identifier for the router, is going to be the LDP router ID separated by a colon and then a 0. And the question is always, well, what does that 0 represent? Well, with respect to the label distribution protocol, there are two types of label spaces, right? So the first is interface specific, and that might be if you're doing something like ATM, okay, where the labels are being allocated on interface specific scales, right? The second is going to be the platform-wide label space. And the platform-wide is the one that we are interested in because that is the default and the standard on Cisco routers. So if it's platform-wide, it gets a 0 right here. And that's why on Cisco platforms, you're going to typically see that that is always going to have a value of 0. And again, there are two label spaces. You've got the interface specific, which would be relevant if you were doing something like ATM. And then on the other side, you've got the platform-wide label space. And again, it's just how the labels are being allocated. And remember that the LDP labels are locally significant, right? So when we say platform-wide, I'm talking only about router 7, right? So we're on router 7 here. So router 7 is going to have platform-wide label space, but it's mutually exclusive from all the other routers. Again, it's local to the router is where it's significant. It's locally significant to the router. So again, those are the 6 bytes that you see here in the peer LDP ID. Again, we've got the connection information showing that the connection was initiated from router 8 out one of the random high ports to port 646 on router 7. Now, you'll notice that we don't have anything here that talks about session protection. So let's enable session protection, because what we're saying is we want to make sure that if the connection between router 7 and router 8, that directly connected link there on Ethernet 01, if that interface on either side goes down, I want to ensure that we don't tear down the label distribution protocol adjacency that's already been established. So let's see what that looks like if we tear it down. So if I go to Ethernet 01 and I say shut, we're going to receive the LDP neighbor change message here that says the neighbor 8888:0, right? And again, remember, so this is identifying it by the label distribution protocol, the LDP ID, right? And it says that the adjacency is down, and the interface, and why is the adjacency down? The interface is not operational. So again, do we really need to tear the adjacency down here? Because router 8 clearly has 2 additional avenues that are not directly connected through which he can reach router 7. So let's go ahead on router 7. Let's bring this interface up. So we'll say no shut. And as you can see here, we've got the LDP neighbor change for router 8, right? It shows that it's back up. So we've got messages being sent back and forth. The label mappings are being exchanged. And let's go ahead and give us some room here. And then our OSPF adjacency has also come back up, right? It's gone from loading to full for between router 7 and router 8. So if I were to say MPLS LDP, and I think it's discovery, no, sorry. Session protection. All right. So MPLS LDP Session Protection, this is the command that on router 7 is going to enable session protection. So I'm going to enter this command, and then let's take a look now again, and we want to look at the do show MPLS LDP neighbor, and we want to see the detail. If I just do neighbor, right? Neighbor doesn't give me much information, at least information specific to what I'm interested in here. So I see kind of the same information. It shows my discovery sources, it shows the TCP connection's been established, and it shows that we're sending and receiving and that our state is operational, right? And that's great, but I'm interested in the session protection feature. So let's take a look at the detail for peer 8.8.8.8. Now, what do we see that we did not see before? And it's this LDP session protection enabled. Now, the key right now is that the state is incomplete. Because again, remember, as soon as I enabled this command, and this is also proof that when you enable this command, it doesn't disable the LDP link hellos, right? Or the LDP link adjacencies, which are the ones that are directly connected, because I am still maintaining my adjacency with router 8, right? Remember, we just did the show MPLS LDP neighbor without the detail. You can see that this is up. I am up and operational between router 7 and router 8. So just because I type in MPLS LDP session protection doesn't mean that all of a sudden everybody has to be capable of accepting targeted hellos, right? Because remember, when I typed in that command, MPLS LDP session protection, I am now also sending targeted hellos to anybody and everybody that I can reach. But I'm also maintaining my link hellos, right? So I'm actually doing both. I'm maintaining my directly connected LDP sessions via the link hellos. However, I'm also, by issuing that command, saying that if anybody out there is accepting targeted hellos, I would also like to initiate session protection with you so that if my directly connected link goes down, that I don't tear down my LDP adjacency with you. And so right now on router 7, and let me change the color here, and I think we're gonna, I think I'm still green. Yeah, let me come up here real quick. Let me change over to red. So what I'm saying here is when I enabled session protection on router 7 is now sending out his desire to create, right, or he's initiating with targeted hellos he wants to initiate session protection with anybody else out there who's capable of doing or accepting targeted hellos. So now that brings up an important question. You'll notice that if I run that neighbor detail command again, we still see that the state is incomplete. And what this indicates is that I've been incapable of establishing an LDP session protection session with any of the other routers. Because remember, by default, LDP does not accept targeted hellos, right? So this is something that you have to explicitly configure on the router to say, okay, I want this router, in addition to accepting the LDP link hellos on its directly connected links, I also want this router to accept targeted hellos from any routers who are out there that would like to establish LDP session protection with me. So we're going to work between 7 and 8 here. Let's work our way over to router 8. And we'll go into global config mode here. And I'm going to say MPLS LDP discovery, right? So this is the LDP discovery that we're worried about. And I'm going to say targeted hellos accept. And we're going to take a look at the from, and we're also going to take a look on the other side, on router 7 side, to maybe specifically hone it down into a selective group of hosts that we want to set this up on. So I'm going to say MPLS LDP discovery targeted hello accept. So this is the command that needs to be configured on any routers where you want that router to accept targeted hellos. And again, how does the targeted hello get activated? When we type in that MPLS LDP session protection command. So these are inextricably linked, right? As soon as I enable session protection, that router is now sending targeted hellos out to the neighbors that he knows about so that he can try to establish LDP session protection with that neighbor. So let's come back over here to router 7 and let's look at the output of the show MPLS LDP neighbor detail command one more time. And what do we see that's changed here? The state, right? So instead of the state saying incomplete, and again, it was incomplete because nobody else was configured to accept the targeted hellos. Now we've configured it on router 8, so my peering here with router 8 says LDP session protection is enabled and my state is now ready. If we scroll up here to router 6, LDP session protection is enabled, right? Because again, I've typed in on router 7, I'm sending targeted hellos. I've typed in MPLS LDP session protection. So he is notifying his directly connected neighbors that, hey, I want to do MPLS session protection with you. But again, the state is incomplete because router 6 has not been configured with the MPLS LDP discovery targeted hellos accept, because by default LDP does not accept targeted hellos. So that's going to be incomplete. However, here we're ready. So let's go ahead and go into interface E01 and let's shut that interface down and let's see what happens now. You'll notice that we don't get a label distribution protocol message to the console here stating that the LDP session is down. If I roll further back up here to where we took a look at that earlier, and that was it right here. So you can see the LDP neighbor change, the neighbor is down, the interface is not operational. The directly connected interface is not operational. However, what do we see this time? This time we're being told that LDP session, and that's that SP, session protection with router 8, session holdup initiated. And we know how long it's going to try to maintain that session for us, 86,400 seconds, which if I'm not mistaken is 24 hours. So again, it's going to attempt to hold that session up for 24 hours. So how is that working? Well, if we come over to router 8 you can see that the OSPF adjacency went down, but we didn't lose a path. So do show IP route. We didn't lose our path. So how is router 8 now getting to 7777? Well, he's going through router 5, right? So which alternate path is this being maintained on? We can see that router 8 knows, hey, I can still get to 7 by coming to 5 to 6, and then down to router 7. And how does 7 know about router 8? So if we were to say do show IP route, you can see that to get to 8.8.8.8, he goes up to router 6, who then goes over to 5 and then down to router 8. So that's really what session protection is all about. I'm able to maintain my LDP adjacency via targeted hellos, right? And the targeted hellos, and I probably shouldn't have drawn this down here by 8, but the targeted hellos are being sent from router 7 to his directly connected peers here. And any of those directly connected peers who has an alternate route that is not directly connected, in order to get to router 7, if the directly connected link or links go down, the LDP adjacency is going to be maintained. So let's go ahead and do a show MPLS LDP neighbor detail again here. And did I get that wrong? Do show MPLS LDP neighbor detail. There we go. All right. And what is our state now? The state is protecting. You can see we've even got a hold up time remaining, right? So we've got 86,225 seconds left before the adjacency is eventually torn down. So now remember, when we took a look at the MPLS LDP, and let me get out of here, interface config mode here. So when I said MPLS LDP Session Protection, you see that I could set the duration, but I could also declare who I want to set up the targeted hellos with, right? Because again, remember, right now, router 7 on any interface where I have MPLS IP, or on any interface where I'm running OSPF, if I were to have the MPLS LDP auto config command turned on, I'm sending targeted hellos right now. So what if I want to say, I don't want to send targeted hellos to router 6, I only want to send targeted hellos to router 8. Now remember, right now, what does router 6 show? So this is proof right here that 7 is sending targeted hellos to 6 and to 8. However, only router 8 is configured, and it's actually up and working right now, right? Because we've torn down the directly connected link. We shut that link down. So router 6 is receiving the targeted hellos. Router 7 believes that he is trying to establish LDP session protection. It's incomplete because by default, again, LDP does not accept targeted hellos. So if I want to make sure that 7 and 8 are the only two participating here, when I set session protection up on router 7, I can go ahead and put in an access list. So I'll just call this session protection underscore router 8. Now we're going to have to create that here in a second, which we'll do. And let's change our duration. So I'm going to say that I don't want it to be 24 hours. I want it to be 12 hours. So if after 12 hours, that directly connected link that exists right here, if that link doesn't come up after 12 hours, you know what? Go ahead and tear down the LDP adjacency, because we may have a bigger issue, right? So MPLS LDP Session Protection 4, and this is again just going to be a standard access list. I'm giving it a name. And then the duration, how long do I maintain my LDP adjacency via the non-directly connected path before I tear it down? So we're going to say 43,200 seconds, and that exhausts the options there. So let's go ahead and say IP access list standard SP underscore R8. And I'm going to say permit. And again, remember, on router 7, who do I want to permit, or who do I want to allow these targeted hellos to be sent to? Well, I'm going to send it to 8.8.8.8, right? So let's enter that in. And let me go ahead. I'm going to bring that link back up, interface E01. And let's go ahead and say no shut here. So you can see that the interface is going to come back up. And we get a nice message here telling us, hey, LDP, Label Distribution Protocol Session Protection for the LDP ID 8888:0, which is router 8, session recovery succeeded. So again, the session is reestablished without ever being torn down, right? And that's the key, that's the critical point about LDP session protection. So now I've got this access list on here. So what if I were to say, and let's get out of the interface config mode here real quick, do show MPLS LDP neighbor detail. Let's take a look now at the difference in the output here. So let's start up here at router 6. What do you notice that's different in the output between 6 and 8? And if you are recognizing the fact that this LDP session protection information is no longer here, you're absolutely right. And so that's what that access list accomplishes for us. Again, if I don't want to try to do session protection between 7 and 6, then I'm going to explicitly define via a standard access list the routers with whom I do want to do session protection. So again, this is proof that that access list is preventing router 7 from sending targeted hellos to router 6, because there's no information here that indicates that session protection is being set up. So what do we have here? So LDP session protection enabled, and the state is ready. And again, you can see we've got the 43,200 seconds here. And here's the name of the ACL, the standard ACL, which is just session protection _ router 8, that's actually facilitating this communication right now. Now again, let's go back over here to router 8. Remember on router 8 when we set up the MPLS LDP discovery targeted hellos, and we said accept. It's the same thing on this side, right? So I can enable targeted hellos, and if I say MPLS LDP discovery targeted hello accept, it's the same thing as when I typed in MPLS LDP session protection. When I type in MPLS LDP session protection, router 7 is going to try to establish a targeted hello setup with any other router, with every router that he's directly connected to. And it's the same thing with the targeted hello accept. When I say this, MPLS LDP discovery targeted hello accept, what I'm saying is I'm willing to accept targeted hellos from anybody out there. So on router 8, what this command means is, hey, if router 5 sends me a targeted hello, or if router 9 sends me a targeted hello, or router 7 sends me a targeted hello, I'm going to accept it. Now that may be what you want to do. If it's not, and again, in our use case here, this is just to sort of exercise some of the different options and variables that are available to us. We only want router 8 to accept targeted hellos from router 7. So I would say from, and again, it's exactly what we just did. So I'll just say targeted hello from router 7 is what we're going to name that access list. Now, I need to make sure that I configure that access list. So IP access list standard, and it's going to be targeted hello _ R7. And I'm simply going to say permit. And let's actually do this. I'll put in here permit 5.5.5.5, and we'll leave it the way it is right there to prove that this is going to do a quick sanity check on targeted hellos that are coming in. So what do you think is going to happen now if I come into, and first let's run this. If I say neighbor detail, let's see what we get here. So we're ready to go, right? Session protection is ready to go. If I go in interface Ethernet 01, what do you think is going to happen? Is it going to work, or is router 8 going to say, let me look at this access list I've got to determine if router 7 can legitimately send me targeted hellos? So if I say shut, and we shut this interface down. Now watch what happens. You'll see that it thought that the session holdup was initiated, right? Because again, everything that was happening up until that point, and that's what we're looking for right here. So everything that was happening up to this point, router 7 legitimately believed that he had a session protection, LDP session protection adjacency set up with router 8. However, router 8, we applied that access list, and so look what happens here. Received error notification from peer. So router 8 notified router 7 that, hey, the LDP adjacency is going to get torn down. And why is that? Because he's not allowing those targeted hellos to come in. The session is going to be torn down. So if I say no shut, right, it's going to bring the session back up. If we say do show MPLS LDP neighbor detail, what's our state now? Because remember, it was established before, then we added the ACL. So when I turn the interface back up and he goes to send targeted hellos over to router 8, now the access list, right, is going to look at it immediately, and he's going to come back and say, hey, it's incomplete, right? Because I'm trying to send targeted hellos over there, but they're not being accepted. So the state, again, is back to incomplete, which was, if you think about it, how we initially started out. Was we enabled session protection on router 7, stating that router 7 is desiring to, or is desirable, that's a bad choice of words there, that router 7 wishes to maintain his LDP adjacencies with his directly connected neighbors if the directly connected link goes down and another path exists via the IGP to get to router 7. And so this is what we're seeing, because again, router 8 is saying, hey, I am only interested right now in allowing targeted hellos from router 5. So let's go ahead and add in router 7 here, and then we'll wrap up. So we'll say permit 7.7.7.7. Right? Let's come back over here to router 7, because remember, router 7 is sending targeted hellos. And where are we at? Yeah, because remember, router 7 is sending targeted hellos to his directly connected neighbors, and that's something that's going to continue to take place. But again, router 7 has an access list that says you're only sending targeted hellos to router 8. Because again, you can see here there is no LDP session protection information that has been entered in here for router 6. Because router 7's access list says you can only send targeted hellos to router 8. And now router 8's access list says you can only accept targeted hellos from router 5 and router 7. So again, our state is ready. And you can see here that that's the ACL that is allowing me to send the session protection targeted hellos. So let's go ahead, let's shut the interface down, and let's confirm and prove that with ACLs on both router 7 and router 8 respectively, router 7's ACL is dictating who he can send the targeted hellos to. Router 8's ACL is dictating who he can receive the targeted hellos from, and let's see, does it maintain and protect this label distribution protocol session. You can see right here that as soon as we down the interface, LDP session protection message saying session holdup initiated. Let's take a look at the neighbor detail output for LDP. Again, router 6, nothing going on here, because router 7's access list says he can only send to router 8, only send the targeted hellos. We come down to the router 8 peer LDP information, and there it is. The LDP session protection is enabled. It's actually working. It's protecting. It's the ACL. This is our ACL, the standard ACL that dictates who we're sending targeted hellos to. That's the duration that we entered in for 12 hours. After 12 hours, it's going to tear down that LDP adjacency between 7 and 8. And how much time is remaining in seconds? 43,162. All right, so hopefully this is explained and provided some clarity around what MPLS LDP Session Protection is all about. Remember, we set up LDP Session Protection between two routers that have directly connected links if we have a second pathway to get to that router that is not directly connected, and we want to maintain that label distribution protocol adjacency between those two routers in the event that the directly connected link that's providing that adjacency goes down. Another key takeaway to remember is that when we enable session protection and the session is set up and it says that it's ready, that doesn't mean that we are no longer sending link hellos. Remember, you're doing both, right? So the link hellos are getting set across that directly connected link, and the targeted hellos are getting sent as well, right? So both of those are in effect. And again, we also saw on router 8 where, and let me go ahead and say do show run section MPLS. So you can see that we've got the MPLS. This is the key command here that we set up the session protection with the ACL on router 8. If I say do show, and let's do a do show MPLS LDP neighbors, right? Do I still have my adjacency over here? What does router 8 think is going on? And he does, right? You can see it actually, and actually this is great output right here. When I just do the neighbor command, you can see that targeted hellos are coming in. And I'm passive, this is router 8, is passive because I'm receiving the hellos. Let's see what that looks like over here. We'll pull the detail off. What is the targeted hello status for router 7? It's active because, again, router 7 is actively sending targeted hellos. So to wrap up here, do show run, include MPLS, right? And here was how we say we want to accept targeted hellos. So remember, there's two variables to the MPLS LDP session protection equation. The first is enabling MPLS LDP session protection on one of the routers. The second part of this is enabling targeted hello acceptance on the other. Without both of those, you are not going to get session protection, and we saw that. All right, so this wraps up my video tutorial on MPLS LDP session protection. Again, I hope that this has clarified not only the feature, but the configuration options for LDP session protection and the sort of why. Why would I want to enable it? And you can see that it's probably a good idea to have this enabled because you don't want to be tearing LDP adjacencies up and down. Maybe you've got a link flapping for whatever reason when you can maintain it via an alternate path. All right, thanks for watching and enjoy the rest of your weekend.